So our first speaker is going to be David Barfield. And David is a water resource engineer and consultant. He graduated from KU in civil engineering in 1978, has a master's in water resource engineering in 1991. He's worked in water resources ever since that time, since 1978, worked in consulting, did some work in I believe some nonprofit work in Africa, did some water resource consulting in Africa early in his career, joined Division of Water Resources in 1984 and worked his way up to become chief engineer in 2007, and just retired from being the chief engineer in March of 2000, and now has his own water resource consulting firm, and obviously has been involved during his tenure at DWR and now in consulting in a number of issues all across the state, but certainly focusing on the Ogallala, which I know he's going to talk about here today. Our second speaker is going to be Monty Teeter. Monty is a lifelong resident of Grant County. Born in 1953, he's been involved in irrigation and farming his entire life, has owned and operated Center Pivot or an irrigation firm for many years, including being the largest dealer for Lindsay Manufacturing from 1985 until the middle 90s, with dealerships in North America, South America. And so he as well has got some international experience. A few years ago, he started Dragonline, an offshoot of subsurface drip irrigation. I'm sure he's going to talk about that. And recently was the new product of the award in new product of the year award in 2016, and Innovator Year Award in 2019 by the International Irrigation Association, and was the 2020 runner-up for the Kansas Exporter of the Year. And so now, since 2020, has sold his pivot business and focuses solely on Dragonline. So we're going to hear from Monty after David. Looks like it's going to be a tag team with Dr. Heidi Mehl leading off in our third spot. She is a water and agricultural programs director with the Nature Conservancy. She has been researching water issues in Kansas and abroad from her undergraduate years at the University of Kansas, where she received both a BS and an MA, and received a PhD from the Department of Geography in Kansas State. So Heidi's got the good coverage of making sure she's got both KU and K-State on her resume, so she can talk to anybody in the state. So she is focused on fluvial geomorphology, nutrient cycling in the riparian zone, and cultural aspects. And like our two previous speakers, has some international experience as she's cooperating with the university in Siberia, Russia as well. So Heidi, thanks for being with us here today. And again, Lee Wheeler and Jonathan Aguilar, I believe, are going to be helping out Heidi in her presentation as well. Bob Jurgens is the director of the Bureau of Environmental Remediation at KDHE. He's been involved for over 27 years, environmental consulting and regulatory field, held several major positions at KDHE since 1988, and currently oversees 5 sections. And I have to read this list because when I read that, I was like, that is a lot to cover, Bob. Oversees bankruptcy, brownfields, dry cleaner remediation, environmental liability release, environmental use control, federal facility, natural resource damages, orphan site, risk management, site assessment, spill response, state cooperative, storage tanks, superfund, surface mining, and the voluntary cleanup programs. So if that's not a full week, I'm not sure what is. But again, I thank all of you for being willing to share your time and your expertise. And again, I think we'll have a great session. And so, David, I'm going to turn it over to you now. And if you are ready, take it away.
All right. Can you see my screen?
I can see your screen.
All right. Well, thanks very much for this opportunity to visit, and look forward to discussing this and your questions. Talking about progress in the Ogallala Aquifer. I'm gonna emphasize GMD1 because I'm doing some work for them to support that work, but obviously we'll talk about GMD4 in the process as well. So, all right. Why is my slide not moving forward? Hold on. There we go. So just to be clear, we're speaking about Western Kansas and the Ogallala proper, low recharge, significant use therefore declines are the perennial problem, and how to address the overdevelopment of that resource is the subject of our discussions here. So this is a depiction that most of you have seen of the percentage change in the aquifer over from pre-development to current. So we have 3 groundwater management districts over the 3 sort of portions of the Ogallala. Northwest Kansas, GMD number 4. We'll talk about it briefly first. It was the initiator of the LEMA concept, and you know, the first LEMAs were developed there. And then I'll go to GMD1 and its LEMA activities of recent years and ongoing right now. So again, this became a problem in the late 60s and certainly early 70s. We began to recognize those declines, and the legislature has acted to support action to slow those declines and you know, extend the life of this aquifer. I'll just focus on the 3 of these acts: formation of GMDs, the IGUCA statute provisions, and LEMAs. But certainly other action is also making a difference. So groundwater management districts were enabled by the act in 72. 5 of them were formed in the 70s, 3 over the Ogallala. These districts moved fairly quickly to develop rules to require spacing of new wells, eventually slowing new development and actually closing the Ogallala over time. Metering studies, but nothing to very limited action to actually address the overappropriation to scale back the use of the aquifer. So in 1978, the legislature allowed for intensive groundwater use control areas, basically to address identified problems in identified areas. Especially groundwater declines. It requires or allows the chief engineer to conduct hearings to determine what to do to address those problems and to make a decision based on that hearing record. So we have 8 IGUCAs, and I'm not going through the specifics here, but the thing I want you to see is while the IGUCA provisions were requested by groundwater management districts in the Ogallala, we have no IGUCAs in the Ogallala to address overappropriation. So fast forward over 30 years to 2010, we still have not done anything significant to address overappropriation. We've done other stuff. We had a group of water users in Northwest Kansas in the Sheridan area that wanted to cut. They wanted to jointly reduce pumping by 20% to extend the life of the aquifer. And we looked at an array of choices and tools to accomplish that, and none of them worked. So Wayne Bossert, GMD4's manager at the time, outlined a new approach that required new legislation. And in 2012, the legislature amended the GMD Act to allow for local enhanced management areas, LEMAs. Shortly thereafter, GMD4 initiated the LEMA for that Sheridan area. It required a 20% reduction and implemented corrective controls to accomplish that for the period 2013 to 17. They basically allowed 55 inches per 5-year period on recent irrigated acres. The actual savings in that first 5-year period was approximately 35%, so a very successful initial 5-year period. So they renewed their LEMA for 5 years, and they're basically in the process of extending it still further. So again, just the basic provisions of the LEMA statute. Again, it's an alternative to that IGUCA process, but instead of the chief engineer conducting the hearings and deciding what to do about it, and that was really the reason that these were never initiated in the GMDs, is the decision of what to do was ultimately the chief engineers based on the hearing record, and there was always a concern that more would be required out of that LEMA process than the GMDs desired. So Wayne Bossert's idea was let's let's have instead the GMD develop the plan, define the goals, how much they want to accomplish, what they wanted to do to accomplish that goal, and then have the chief engineer conduct the hearings that are needed, sort of a due process requirement. But the hearing would decide should the GMD plans be approved or not, essentially. So the heart of LEMAs are its corrective controls, typically allocations. LEMAs provide flexibility, multi-year allocations to accomplish those reductions and maximize the economy with those reductions. So based on the success of the Sheridan LEMA, GMD4 did an extensive district-wide LEMA, not as aggressive. The allocations are a bit more generous, but it basically gets everybody in areas of decline in the game. That plan was adopted for 2018 to 2022, and again, GMD4 is looking to extend that through initiating the hearing processes soon. That LEMA went through a pretty extensive judicial review and was found, with people questioning whether LEMAs were really constitutional, and the judge found that it was constitutional and duly adopted. All right, so now I'd like to spend the rest of the time in Western Kansas, GMD number 1 again. It's this brownish, it's the area that's the most brown, has it's the most depleted of the GMDs. And we're actually going to look at Wichita County, which is in the center here, which is actually the most depleted county of the GMD to start with. This is a map showing the remaining saturated thickness. So after that 60+% reduction in saturated thickness, what is left? So just for reference, the blue areas have more than 50% of remaining saturated thickness. The green and browns have less. So, and again, Wichita County is a central county here. It averages just under 25 feet of remaining saturated thickness. So very significantly depleted, but despite that, still some very important economic uses of water occurring there that the water users want to see continue and extended, including both irrigation and also a lot of high value animal ag, feed yards, dairies that require water in the feed base of the area. So there's a lot of interest in finding ways to extend this resource because of those benefits. Before I get into specifics, I wanted to talk a little bit about research on producers' attitudes towards groundwater conservation generally, and then towards LEMA specifically by two different researchers. And this was presented at one of the Governor's Water Conference, I believe in 2019. And so this was part of a broader study of the Ogallala, but the K-State researchers, really looked at the results of the broader study to see what Kansans thought. And they found that Kansas producers overwhelmingly support groundwater conservation. And the primary motivation of that is to support their local economies and, about providing for future generations. But they also found that most people believed, most producers believe they are already doing all that they could individually do to conserve. And again, but producers in LEMAs and water conservation areas are demonstrating that more can be done. So how do you get there? And the way you get there is by the local leadership really supporting the discussions about how do we move to get everybody in the game to increase their conservation efforts to extend this aquifer. So GMD1, as part of their efforts to figure out how to move forward with LEMAs, supported some research, basically a survey by Dr. Hendricks out of K-State again, to look at producers' attitudes about water conservation in GMD1 specifically, and specifically about, do we use the LEMA tool? And if we use the LEMA tool, what type of reduction goal do you support? And what method to accomplish that do you support? And they found strong support. We need to conserve water, strong support for use of the LEMA tool as a way to get it done. they ask about different how much reduction. So there's good support for 15% as a reduction goal, less as you got more aggressive. But Dr. Hendricks found that as to the specific method of accomplishing the goal of allocating the water, there was a lot of disagreement. Some people favored one and other people favored others. So talking about their LEMA efforts specifically, GMD1 actually, after the Sheridan success, worked to develop a district-wide LEMA in 2013 and 14. They actually developed a plan. They worked with their water users. GMD1 decided they wanted to put it to a vote, and they wanted 2/3 of the voters to support it, which did not occur. So that sort of stalled their effort. So Wichita County water users still wanted to move forward with reductions. So they developed a countywide water conservation area. Water conservation areas allow for voluntary enrollment in conservation plans, again, providing flexibility. And so they had an extensive process to develop their WCA. It requires, it's a 28-year WCA, required reduction starting at 29%, going up to 50% over that period. They got 20% of the people in, but that wasn't enough. So the steering committee encouraged the GMD to develop a Wichita County LEMA. 2018 to early 2020, the board discussed and developed that LEMA plan. It's not as aggressive as the WCA, but basically, again, gets everybody but very minor users in the game, most getting a 25% reduction from that LEMA, and that's in effect for 2021 to 2025. So finally, the board has always been interested in all of this district needs a LEMA. All of it needs to extend the benefits of this aquifer. They chose to move forward with Wichita County because they had the broadest support and it was the most need for conservation to occur, and as a learning process. But as soon as sort of the hearings were essentially over and the decision was about the Wichita County LEMA was in the chief engineer's plan, they began to work on looking at the other counties and what do we do. And just want to give some kudos to Kyle Spencer, the manager, and the GMD1 board. They've expended a lot of time and resources for this discussion that we've had over the last year to occur. Over the first several months, we sort of looked at sort of the broad parameters of that LEMA. LEMAs have to carefully balance sort of, making sure they work today for today's economic uses, but extend that resource. And so there's a careful balance that sort of has to occur. And so they, to get to sustainability is a big lift. So they decided that wasn't the initial goal, but they wanted a significant step toward that goal, looking for an overall savings of 10 to 15%, a maximum reduction to any individual water user of 25%, and providing as much flexibility as they can. So the challenge was finding that acceptable allocation system. So we've been on a journey to look for that. They didn't want to use the Wichita County flat fixed reduction on water use, but they wanted to do inches like GMD4 did, but the amount of water left in GMD1 is just insufficient to allow the number of inches that are desired, and it would sort of focus all the reductions on a fairly small group of people. So ultimately they came up with a hybrid that used the historic water use record but varied the percentage reduction on a sliding scale. So we're still working on it. We're actually working on the last piece of sort of the process, which was an appeal procedure. They're basing allocations on historic use, and so statute requires that they give due consideration to past voluntary conservation in that water use record to make sure we're not punishing people for conserving. So we're sort of working on that last piece. We spent about 3.5 hours on it yesterday at their regular board meeting. County meetings are coming up for more input, present the plan, at the February 2022 annual meeting, submit the plan in spring of next year, and if approved, move forward. So in conclusion, LEMAs, I believe, are an effective tool to make joint progress to reduce the declines and extend the life. The development of LEMAs is a significant effort by local leadership, specifically the GMD board, to develop what is that supported goal and what is the best way to accomplish that. One last observation, as we look at what Sheridan accomplished and what it, preliminary looks at what the broader GMB4 LEMA is accomplishing, what WCAs are accomplishing, these LEMAs seem to be accomplishing more than just their stated reduction as we sort of move water users from this sort of single year optimization to sort of multi-year management. So, all right, I am done. Thank you. I guess I can take questions now. Is that the plan, Earl?
Yeah, we have a few minutes, 2 or 3 minutes here for questions. I don't see any in the chat. Is there anybody that wants to unmute real quick and ask David a question?
Dave, this Monty, Teeter, and I thought one of your comments was very profound, finding the acceptable solution, to that everybody's willing to change. And you have so many different growers that some are new growers that have to make huge farm payments. Some are have their land paid off and they just going to use water until they run out. And then some are really cutting back, trying to save water. So it's really a challenge, your position to what you're trying to accomplish. So thanks for doing everything you can.
Sure. It is a challenge. GMD1 has a pretty diverse. They have areas that are nearly done, low production wells. But they have other areas that the Wescan area is a very unique area geologically. Have some really high production wells there, and so how do you have a LEMA that sort of has everybody contributing? Because those low producers, there's a lot of them, and they matter too. So sort of dividing a set of corrective controls that sort of works for all those different situations is their challenge. So
Great. Kay, go ahead.
Hey, I have a question. Mr. Barfield, with your experience in the Department of Agriculture, do you think can you give us some suggestions on ways that we can more effectively manage appropriations?
Well, I guess, I think I've sort of said here, LEMAs are definitely, where you can have the GMD and the leadership to engage water users and come up with a joint plan. They basically sort of require, more can be done. Everybody thinks, as that research says, that they're doing as much as they can. Our water users out there are not wasting water, but there's actually ways to be more efficient. And so it sort of requires everybody to be more efficient. Certainly the water technology farms and the demonstrations that those are doing are I think, a very significant thing. Individual water users can make a big difference on their own. It doesn't require the joint action of LEMAs, but demonstrating the technology and the methods that where producers can maximize their profits with less water is certainly very significant. So those are a couple of things. Supporting LEMA development, water technology farms are a couple of the big things that come to mind.
Excuse me, if I can just do a follow-up. What about the legislatively?
Well, I think the legislature has given us a pretty good set of tools. In addition to those two I just mentioned, there's water conservation areas, and this is where an individual large producer or a set of producers in a specific area can develop their own plan to conserve water and get some of the same flexibilities. GMD3 does not have any LEMAs, and the board supports LEMAs only after the water users sort of come up with a joint plan. So we've had a large group of water users in Finney County and Kearney County, just north and west of Garden City, that have, there are, I think, half a dozen WCAs that involve tens of thousands of acres that have voluntarily enrolled in a WCA. So So the legislature's given us the LEMA tool, the WCA tool, it's funding through the state water plan, these technology demonstrations. So I don't know, you know, we've spent a lot of time thinking about it, and we sort of got everything out of the legislature that we know to do. I don't know if Earl has a follow-up there.
Well, unfortunately, I've always got an opinion, but unfortunately, I think we're going to need to, in order to stay on time. First of all, thank you, David, for the presentation. I think a great way to kick us off in this session. And your experience is fantastic here as we set up the discussion for the rest of the folks. I'm going to go over to Monty Teeter. You just heard him ask a question a minute ago, but he's going to talk about the benefits of mobile drip now. So Monty, I think we're ready for you.
Monty, you're on
Monty, you
mute.
need to unmute there, I think.
A good thing to do. Can you
There
hear
you
me?
go. Yep, I got you now.
Okay. Can we see a screen?
I can see your screen. Yep.
I'll there you go. Do you have a single slide now?
Nope, we still have the slide. There we go.
Okay. It's going to delay just maybe a little bit, but
Sounds good.
okay. Well, I appreciate the opportunity to come share about our technology that we've developed. In some of your introduction there, you know, I did start in the irrigation business at age 19 and sold my business last year. We have sold over 3,500 center pivots around Southwest Kansas and Eastern Colorado. And also, we also sold thousands of acres of subsurface drip irrigation, which got me thinking about what we can do to save more water, because with drip, we could always save so much more water than using pivot nozzles. But, you know, when you don't know how much water you're going to have or how much time you're going to have to utilize it, it's hard to make that investment of $2,000 to $3,000 an acre if you don't have water. So that's been a real challenge to get people to think of doing something different. So I started at age 59 on some way to start saving water, and I'll go through some of the things that we've came up with now. I just want to share that mobile drip irrigation is not another sprinkler nozzle. Just to reiterate that, it is not another type of sprinkler nozzle. Mobile drip irrigation is mobile surface drip irrigation. And it has special unique practices that we need to consider. You must have filtration. You must check the emitter tubing once in a while to see if you have any intrusion from organic material or iron bacteria or some other things like that. It's dispersing its water through some small emitters, so we need to focus on that it is a drip system. But not to take too much time on talking about that, but we've combined the efficiency of drip irrigation technology with the economics and flexibility of pivot and linear irrigation. And what I mean by that, we always found that we could save at least 30 to 40% more water with drip over pivots, but the cost was so much there. But the cost of the pivot, even with a dragon line system or mobile drip irrigation system on it, will be more than half the cost. And it has so much more flexibility. You can start and stop it with your cell phone. You can change direction. You can change prescriptions. You can water by time. You can water by degrees. There's so many more things you can do to control any runoff, for germination practices, so many other things you can use a pivot for. So that led us to trying to develop this system. And I'm going to play a small video that just describes what is Dragonline mobile drip irrigation, and it lasts about 59 seconds.
Dragonline is a patented and trademarked technology that combines drip irrigation with pivot irrigation. Dragonline provides increased efficiency by delivering water and nutrients directly to the soil, providing optimal plant growth, By applying water directly to the soil and not on the plant, Dragonline eliminates evaporation from the canopy. It also eliminates leaf burn, plant shock from sudden temperature changes, and reduces potential for disease to the plant. Costly wheel track issues are reduced or completely eliminated since the water is applied directly and precisely to the soil behind the system. Its unique design allows for precise chemical and fertilizer application as well as crop germination through the system. Dragonline systems are adaptable to both low and high profile crops in any row spacing and can be used on most pivot and lateral irrigation systems. For more information on Dragonline and to locate a dealer near you, visit Dragonline.
So that's a small video, and you can tell that, you know, as we talk about the governor's conference here and me trying to say what mobile drip irrigation is about, overseas, I have people calling me and setting up with the Department of Commerce, the Kansas Department of Commerce, meetings over in Ukraine area, Russia. You know, I have so much business now in Australia and South Africa. It's just amazing how we're growing other places. Also in Saudi Arabia, we just sent 2 containers of product there this last month. And looking at large projects in Egypt, but there they're not bickering about different ways to save water. They have to save water. So in that, I'll just share why we have developed the Dragonline. This is a new version that we have developed after the 8 years of trying to do different designs. And, you know, since we came up with the concept, we've had to design, we've had to implement it into the market, and then market it around the world. And it's always, what style do I need? How do I utilize it? How can I make sure that if I grow cotton this year, I can grow corn the next year? And we've developed this new hybrid system. And if you bear with me just a moment, I hope you can see my cursor on the screen. You know, we have the Dragonline drip tubing that drags on the ground, and that's why that's the name mobile drip irrigation. We've developed a flexible flex hose that, as you reverse, this system will or the tubing or the hose will curl around and the tubing will follow it without kinking. We've developed a special manifold that attaches all the leader lines to it. They can be in any spacing. We have them as close as 12-inch spacing, and we have them as far apart as 80-inch spacings for specialty crops. Then we attach our manifold to a cable system that runs from tower to tower with a unique new patent pending dual cable system. And what this allows us to do is to loosen one dual winch and tighten the other dual winch. And in this concept, you water in a strip, you plant in a strip, you germinate your seed in that strip, and as the seed emerges, then you just simply winch it over 6 inches and water next to that young plant, not watering all that seed bed and wasting all that water and evaporation. So it's a very unique product that we've developed. Also, we have a vertical winch now that, as you loosen the 2 winches on each tower, you can raise up the center winch, and we can raise this manifold assembly all the way up to the top, so we can have 9 foot of clearance, or we can have 4 foot of clearance. So we've really done a lot of work during COVID and during this time to develop a system that'll work anywhere in the world. This is a better picture probably that shows a real picture of working. This is actually in Australia. They planted their corn on the dripper marks. They germinated the corn. They watered next to the corn, and then they moved it over a little ways. And you can see the manifold that stretches across here. You can see a little bit of waffling on this manifold. We've kept that flexible for a reason. We mark that cable that stretches between the towers on precisely 30-inch spacing, and you attach that tubing directly, or the manifold directly to those marks. And sometimes a guy has a skip row that may not be correctly if he's not using good GPS, and he can adjust that accordingly if he needs to. You can see where it's connected to the sprinkler system itself to get water down to the manifold and so on. This is a picture. We always have people ask, what does the tubing look like? How does it work? It's a specially designed tubing that's taken 8 years basically to get where we're at today. We use a 2 gallon per hour emitter. Traditional emitters for subsurface drip are a 0.18 or a 0.2, something like that. This is 10 times larger. So the flow path is much larger, so we can escape a lot of intrusion from contaminants. We can use larger filtration. Our emitters are spaced in the tubing every 6 to 12 inches apart. And the number of the length of tubing is dependent on how many gallons per minute the grower is watering. If the length of the tubing dictates how much water we're applying, we don't change emitter sizes. We just change the length of the tubing. For example, on my farm with only 200 gallons, the first emitter tubes are only 1 foot long and the outside tubes are 18 feet long. So it just changes length as it moves out along the system. They are pressure compensating. And what this great benefit is, inside this emitter, there's a silicon diaphragm that senses pressure. And once you reach 8 PSI, every emitter on that whole system is emitting the very same amount of water. They are self-flushing. If they start sensing some fine sediments clogging a flow path, it'll automatically flush itself. Also, it's made out of 50 mil polyethylene tubing, which is the thickest in the industry that we can use. And then at the end of the tubing, we have a 1/2 inch threaded end cap, which allows to flush out contaminants. As everyone knows, with drip, you cannot filter out silt. It'll always get in the system somewhere, or really, really fine sediments. So this is a way to flush out at the end of your system any contaminants that can get into the system. So it's very easy access to cleaning. This just talks a little bit about the flex line that we have. It's not by accident. We spent about 8 months developing this tubing. It's a 1/2 inch UV resistant, non-kinkable hose. It has very good wear resistant techniques about it. We start off with 11 feet of this soft hose that drags to the ground. And then we attach our dragon line emitter tubing to that. So we get all the drippers laying on the ground dripping, so it doesn't drip down the line and puddle. We want every drop getting into the ground. And also it allows for reversing. Not going to talk too much about the manifold. I've already done that. But the manifolds are produced in 50-foot lengths. The T's are placed in 24, 12, 30, 40, 60 inch row spacings, whatever is recommended or required. All the connections are pinch clamped with stainless steel pinch clamps. Everything we use through the tubing and the plastic fittings are all acid resistant. So we can run any type of acid through this, just like a regular drip system. The manifolds are all tied to the 1/4 inch cable with a 14 gauge stainless steel wire tie, which will never rust. It'll always stay in place. And the manifolds are connected to the drops, and you can use dual valve assemblies. So you can, I think I have this here. So you can use your spray nozzles along with your system to help apply chemicals or different herbicides or different things like that if need be. But today with the new hybrid system, we really don't even need sprays. This just shows, the different spacings of the manifolds. This is actually on a hemp machine in Colorado. This picture here is where a farmer pulled 2 lines together to water on top of beds for watering squash. They're 12 inches apart on, I think it's a 68 row spacing. This picture in the middle is a picture from Paraguay, where they've pulled 4 lines together to water on top of a bed. And this picture is in Garden City, Kansas, watering alfalfa on 30-inch spacing. So we can, basically adapt to any spacing that we need. I'm not going to visit about the cabling system. Don't want to run out of time here. I've got things to visit about. Also, this just shows a bigger or better picture of what our dual winch system looks like. We actually have a winch that is suspended at the center of each tower that has a cable clamp at the top and bottom, which we can raise that up and down to get vertical adjustment. Also, we can loosen one side of the tower and tighten up the other side of the tower to change our spacing of the manifolds. So we precisely place the water on the ground where we want to water, not just throw it in the air. This just shows a picture of the vertical winch system, which allows you to raise the system up. This is watering corn. So you can just see that we can raise it up out of the way to raise corn. This is a high line setting for the hybrid system. This would be a low line setting for more of the milo, cotton, alfalfa, wheat, sugar beets, soybeans, other crops as such. This is actually in Australia, this picture. How and why does mobile drip irrigation save water? We've been on quite a few technical farms, irrigation technical farms, and whenever we use mobile drip irrigation with the use of sprinkler nozzles and they're compared side by side with the same watering, usually we're overwatering with the traditional nozzles, and when we add mobile drip irrigation, we just compound the watering, and the savings that we have, we're just putting more water in the ground. And most crops, once you fertilize for a certain amount of yield and so much water is required, you're not going to increase that yield much. So we did have some disappointing tests, on some of the technology farms, but we were watering the mobile drip irrigation like a sprinkler nozzle, and it's not a sprinkler nozzle. It is mobile drip irrigation. So I want to just share what the difference is. This is on my farm. As a good example, when we first started testing, we show here watering with traditional nozzles, 5 feet apart. I'm putting on 1.25 inches of application. My farm has very limited water. I water 200 acres with less than 200 gallons a minute on 2 pivots. And so one circle takes 8 days to put on 1.25 inches. The other circle takes 14 days to put on 1.25 inches. So I have to make sure that that water is going in the ground and that it's doing good. And as you can see with traditional nozzles, watering slow, even with a low application system, water would start puddling. And when this starts puddling like this, you're melting the soil particles, you're melting them together, you're settling out silt layers, and you're starting to have sealing issues. And anytime you expose water to the surface, you're going to evaporate water. On the Dragon line, this is the same amount of water being applied, and this is the result of what it looks like. There's no puddling, the water gets into the soil, and this is the reason why we had a technician help us with this display to put this into a form where we could help understand and show people better. But whenever you water with conventional nozzles, whether it's sprays or bubblers or any other kind of surface application, you wet 1 to 5 inches of that soil, and you trap air into the soil, into the depth of the soil. And until that air gets out, the water can't get in. And so a good example is next time you have a bottle of water, hold your nose and try to drink it. It's the same principle. With Dragon line or mobile drip irrigation, we water in precise placement. We get deep percolation. The water moves sideways. the air comes out of the soil. So through capillary action, the water is actually pulled into the soil, the air comes out. So the wettest part of the row is underneath the soil, right in the center of where the two drip tubes are emitting water. So in this case, this would be the wettest area underneath this dry spot where the water is accumulating.
Monty, we're about done. We got about maybe 1 minute left. What's your some closing?
Okay, I'll get here to going. The traditional sprinkler heads deliver applications greater than 90% to application, but the losses occur when the water gets to the surface, before it gets to surface through wind and other evaporation. So I used to think this was a good picture of no streaking, but we just sold a lot of evaporators out there. So when we're told, how do we save water? This is how we save water. This was a test done by USDA, and they've shown here that applying 1.2 inches of water and measuring the evaporative loss, that we lose more than 50% of the water on the surface. So we don't want it to get it on the surface. So this was a test that K-State printed. The difference of the percent of difference of soil evaporative loss is 35% less with the use of Dragonline before the canopy closes. So just to add a couple, I might need a couple more minutes here, but I've been asked to do very many presentations on what does savings mean. If we save 300 gallons a minute, this is going from 1,000 to 700. The savings per year is $3,300 per year just in energy at 8-cent electricity, which is higher than that most places. It's 36 million gallons of water a year savings, 110 acre feet of water. So it's a large amount. So with that, I mean, I'm going to go through this very fast, I guess, and to go through some slides. But around the world, we're showing decreases in use of water. We're showing savings up to 50%. We're keeping farmers in business with low gallonage wells. This one farmer said that if it wasn't for Dragonline, he would have had to quit irrigating 3 or 4 years ago. We've increased yields. We've got PepsiCo and Frito-Lay and other companies hiring us to do trials to save water. And this year we saved 20% of the water over traditional heads and actually maintained a good yield. And in the wheat this year, we saved 20% less water and increased the yield 30%. In hemp, we saved 40%, raised a better crop. But mobile drip irrigation brings precise irrigation to precision farming. We keep farmers in business. We keep tax base as irrigated land, not as dry land. We maintain yields with less water. And we provide solutions for precision agriculture. Mobile drip irrigation can grow the same crop with 20 to 50% less water. It's one of those things that we can use to enhance savings. We can achieve efficiencies compared to subsurface drip with 75% less cost. We can save the use of chemicals and fertilizers. We can save 20 to 50% of the energy cost. We eliminate wheel tracks and repairs on center pivots. And we bring a fast return of investment for precision farming. And in conclusion here, mobile drip irrigation water management can help sustainability. I think it was Mike Myers said one time, if we could save 25% of our water today, we may extend our aquifer 35 years. Well, what are we doing today? We're still talking about what are we doing or what can we do? We've got to start saving. We must get rid of the use it or lose it mentality. You know, I've had farmers call me and said, Monty, quit telling people we can use less water. They watch our water meters. They see we use less water. They'll take our water away from us. So we need to devise incentives to reward the growers and not punish them for saving. This is my last slide. You know, MDI will help change the culture of traditional irrigation practices. By 2050, the population will double. Farmers will need to grow twice the food with less than 50% of the water. So how are we going to do that? We have to start doing these new these new ideas. So we just want to bring banking water to the future.
All right, thank you, Monty. That's a great presentation. You appreciate all the work you've been doing, not only here in Kansas, but all around the world. I see that there's a couple of questions in the comments. If you could look those over and maybe respond to those folks, that would be great. We're going to switch over now to focus on the Rattlesnake Creek Irrigation Innovation Project, and Heidi, Lee, and Jonathan. Heidi, can you lead us off?
Okay, is my presentation up there?
We can see it.
Okay, great. Thanks, everyone. Thanks for coming today. And Lee and Jonathan and I are going to tell you a little bit about some grant-funded activity that we have been doing in the Rattlesnake Creek Basin. So just to orient you, if anybody on the call is not aware of where Rattlesnake Creek is located, it's this purple polygon here. That's the watershed. The creek flows from southwest to northeast and flows into the Quivira National Wildlife Refuge wetland complex here in the northern corner. And I'm going to show the same figure that Dave Barfield did, and show that we're focusing on a little bit different area of the High Plains Aquifer. So our target area is circled here. And you can see from this figure, the change in saturated thickness is much different. So we're in a much different hydrological situation in this formation of the aquifer. This is called the Great Bend Prairie Sand Aquifer. Much more shallow groundwater, higher rates of infiltration, and so a different set of challenges than maybe what folks are dealing with in the Ogallala Formation further west. The important point here is that there is not a continuous decline of groundwater, but there is a seasonal impairment that was found in 2015, 2016 related to the water rights of the refuge. So our team submitted a conservation innovation grant, and we were awarded the grant in late 2020. And so this slide shows our overall goals for the grant. We wanted to increase adoption of more efficient irrigation packages, soil moisture sensors, and irrigation scheduling tools, just kind of get some of that technology into the basin to give folks enhanced ability to manage their irrigation water. Number two, monitor improvements in irrigation efficiency and yield per unit water. And then three, facilitate a peer-to-peer mentoring network to discuss successful strategies. Really quickly, through this grant, we were able to offer 50% cost share for irrigation system upgrades. Also free technical assistance. That's primarily been through Lee Wheeler, who you're going to hear from here in just a minute. And then through Jonathan and his team, CanSched irrigation scheduling assistance and workshops. And we had planned for quite a few field days in our original grant proposal. We had to scale those back a little bit due to COVID, but we did hold one in July of this year. So this is our flyer that we distributed to show folks what is available under this grant. And the important point here is that we do require that everybody have that level 1 base technology. That's the monitoring technology, because we want people to be able to see what's going on with their soil moisture, see what's going on with their crop. So everybody has to have the base 1, but then the base 2 is optional, and that's the way we wrote it into the grant. The folks with just the level 1 monitoring technology serve as a little bit of a control for data comparison against those who go to that level 2 and adopt the mobile drip irrigation like Monty was just talking about, or other system package improvements. The requirements for participation in the grant: you have to be located in the watershed. You do have to be EQIP eligible and verify that through NRCS. We're doing continuous signups, and we're just wrapping up year one, and we do have cost share funds still available. So we are continuing to sign up interested folks. And we do ask that folks share their data with us on applied water, crop type, and yields. And we do anonymize the data, except where we have explicit permission to share names associated with the data. So quick overview of our results. We had a goal of signing up 35 fields. We did get 29 in this first year. It's a 3-year grant, so I thought that was a pretty good accomplishment for our first year, especially given the COVID restraints we're working within. Lee's going to talk a little bit about water duty, but the best water duty we had was 21.2 on Milo field and 20.2 on corn. And Lee will go into more detail on those. We estimated a total of over $20,000 in energy savings across all of our participants, across all 29 fields. And then one of our most important findings so far has been the importance of technical assistance. So having that technical assistance for, system maintenance and that well pump performance testing right at the beginning. Some folks were seeing a major improvement just after Lee came out and worked with them on the maintenance of their system and did some of that testing. So that is a big need in the basin and has been one of the biggest benefits of this grant. So I'm going to kick it over to Lee to talk a little bit more about the numbers.
Okay, we had mostly cornfields. So there were 19 cornfields spread over 70, 80 miles from St. John near the Quivira all the way down to the beginning, more near Mullenville, Greensburg area. And it's quite interesting, the range that we had within the participants, 14 farms, 28, 29 fields. And we checked the total water used varied from 11 inches on corn to 21 inches, and the yields were about the same. So the water duty that we like to look at is just the yield per inch of irrigation applied. So in those 19 cornfields, we went from 10 to 20 bushels per acre per inch of irrigation applied. It appears, though, that around 13.5 inches would have been sufficient for good yields from 220 to 280 bushels per acre on those cornfields. If that is so, then there'd be 15 to 20% savings of water. We applied about 3,000 acre foot on those 19 fields, and we could save a little over 500 acre foot if we got closer to the 13.5 inches per acre. The energy savings on those 19 fields is about $20,000. So it's very similar to water. So if you save water, you save energy. We did have natural gas engines, we had diesel engines, and we had electric motors. So the next slide. So we didn't have near as many soybean fields, but just in those 4 fields, we varied from 10 inches applied to 16 inches. So the water duty, using the same bushels per acre per inch applied, went from 4 to 8. And the one that had 10 inches was also an extremely high yielding. The yields on the soybeans were from about 50, that's incorrect, they're from about 55 to over 90 bushels per acre. The 90 bushels per acre was on the 10 inches. Next slide. So this is also has impact on water applied. So on these close to 30 fields, the flow rates varied from 380 gallons a minute to 1,070. The water right allocations for annual amount allowed varied from a low of 86 acre foot per quarter section to over 240 acre-foot per quarter section. All these things affect the water applied. Most fields, I checked the fields from the first week of June, every 2 weeks. I went around to all the fields, checked the water meters, checked the operation, pressures, and then I checked wherever the field was irrigating. I went to the end of the pivot and walked in about one span and checked the moisture on the dry side, just as the irrigation was about to hit it. And on most of those, the driest place in the field had very little deficit. It was more like 90% of field capacity. So things were kept on the wetter side probably than what we needed to. Rainfall varied quite a bit, from 9 to 19 inches from May 15th to September 15th. We did detailed tests, sort of following the NRCS pumping plant evaluation that they cost share on. So we test the well, the pumping plant, and the irrigation system because they all relate to each other. And the next one. So this would be Jonathan or Heidi.
Yep.
Yep.
So
I'm gonna kick it to Jonathan.
okay. As Lee mentioned, there was an evaluation of the system, and that is actually a prerequisite to be able to make a good scheduling. Before you are able to really make a good scheduling of your field, the system has to be operating optimally. And now, if you are able to do that, now you'll have several options to be able to give you a feedback in addressing the question of how much water do you need, when do you need it, and where do you put it. And so basically, just put it into this 3 categories: weather-based, soil-based, and plant-based. And there's a lot of technologies that are addressing some of this. And I think this is one of those low-hanging fruit that in water management that some of the farmers have not really got into. So next slide, please. So Kansked, as I mentioned a while ago, is one of the free weather-based tool that is available for the farmers. And NRCS has been using this in many of their programs. We were able to monitor some of them, all of the fields that were involved in this project. We tried to get as much information as possible, but one thing that we struggled was getting those information of when the water was applied and also the timeliness of that application. But basically, if there is a good data that is coming through, we're able to get the crop ET, which is the consumption of the water, the rainfall that has been received in that field. And there's another term that in terms of rainfall, which is the effective rainfall. So not all rainfall are going to be very productive because it depends on the saturation of the soil. So there is that effective rainfall. The gross irrigation as well as the net irrigation are also being computed. And these are all entered into a database. And the next slide will give you a graphics of what is going on in the soil profile. So basically, this is a summary of one of the field that we are monitoring. We try to, as much as possible, keep the green line, in between the yellow or the amber and the blue, so that the profile is not too full, that it will discard any rainfall, as well as it is not too dry that it will affect the performance of the field. A couple of things that I would just like to mention. You will see that there is irrigation and rain on the bottom, the dark blue and the light blue. There are instances that even if it is raining, you're still able to irrigate just because you know how much water is in your soil. And so I just want to emphasize that item there. And without you knowing that you still have that capability in the soil, those are the things that you are unable to really figure out when you have to start or stop your irrigation system. Again, next slide. I think I'll give it back to Lee.
Yeah, this is just a quick rundown of a detailed example of a field that only had 400 gallons a minute It's shared with another field. The two quarter sections together have an annual appropriation of about 190 acre feet. A new mobile drip irrigation system was applied on both those fields, and they're irrigated together. There was applied 12.7 inches on the corn, and they applied 6 inches on the neighboring field on the milo. And there was about 6 to 7 inches of effective rainfall. The yields, 235 for corn, 130 for milo. It's quite respectable. And so these are the things that we call our level 1 technologies that you have to have to be able to ferret out what's making the improvements in water use efficiency, water applications. So you need a rain gauge at the field with telemetry. It's a step up from a rain gauge on a fence post. A pivot monitoring system that has a pressure transducer at the end tower. Probably 40% of the center pivots I've tested in the last 20 years are operating in low pressure. That means they don't have enough pressure at the end spans, which irrigate most of the acres. So we're not putting the water on evenly on most of our fields, many of them. We also require aerial images, which have several wavelength spectrums to look at contrast, crop growth, soil moisture sensor, and improvements to the irrigation system to apply water evenly to all parts of the field. That just has to be the starting point. You have to put the water on evenly everywhere in the center pivot, all season long, in the high places and the low places. And we also need to do things so that where the water falls evenly, it infiltrates where it goes in. Let's look at the next slide.
Lee, we've got about 1 minute left.
Okay.
Wrap it up.
So here's just an example of what happens not too far west of us, a farm that I work with. They only had 10% of their annual allocation this year. And that's what the reservoirs look like in Western Kansas. Next slide. So here's the pivot monitoring example on this field. The green is where the system was, and each time it peaks is one more revolution. The dark blue is the pressure. And so you have to make sure you can see how much the pressure varies as you go around the field. Next slide. This is the CanSketch graph that Jonathan showed. Next slide. This then is a soil moisture sensor with a tipping rain gauge with telemetry that we had on this field. And you can see the irrigation events are every 5.5 to 6 days. With the mobile drip and the really suppressed flow rates, that's as fast as we could put the water on. We put it on with 1 inch applications. Is there a next slide? And then this is the aerial photography. We wanted to sort of bracket the crop growth in mid-July and in mid-August. And just to see how the effects of different things besides seed planting, fertilizer, previous crop history, the top one's a cornfield, the bottom one's a soybean field. I think that might be all of them. Is there another one?
Nope, that's the end. And I'll just really quickly, because I meant to mention at the beginning that our partners on this grant are Big Bend GMD 5, Water Pack, the NRCS, and K-State, and all of these partners have been really instrumental to our progress on this grant. So big thank you to all of them.
All right, great job, guys. Thanks, and always good to recognize the partnership because that's what gets it done. So thanks for what you guys are doing there. We are going to try and keep moving here. And Bob, if you are ready, I think we're ready for you to take off. And we can see your slide there. Bob, I can't hear you yet if you're talking.
There we go. Now
There
it's,
you go.
you should be able to hear me.
I can hear you. Go ahead.
Amazing. It doesn't matter how many times you try, you can still make that mistake, right? Number one, thanks to the other presenters. I actually started out in the irrigation scheduling world up in Nebraska in the mid 80s. So it's pretty neat to listen to some of this stuff. All right, so let's go ahead and get started. I'm going to be talking today about what KDHE does on the environmental remediation side. And basically, we deal with a lot of contaminated sites. And let's see if I can, there we go. So environmental remediation, as Earl mentioned earlier, we've got quite a few programs that we deal with. Some of them are state lead programs using state money, fee funds, SGF, state water plan, and others are responsible party lead, where we oversee folks like the federal facilities like the Army and the Air Force, and then just the general industry as they do cleanups. A lot of our focus is on beneficial use. The idea is that we should try to use some common sense on how we're going to clean up sites, not throw money at cleaning up a site if it doesn't make sense, and what's the true risk that's out there. But we got to look at what the potential use is for the property when we do that. One of the things we've been trying to do is when we have contamination that's impacting public water supply wells or domestic wells, how do we clean that water up but still get a beneficial use out of it? So can it be put back into a public water supply system? Can it be re-injected back into the aquifer so it can still be used versus essentially letting it go down a drainage creek or and so forth. So over the years, probably the last 10 or 15 years, we've had about 29 systems that we have had that use this idea collectively, over time, and they don't all operate at the same time, but about 2.7 million gallons of treated water in a year. Currently, there are about 14 of those systems running, but still about 1.9 million gallons a year that is treated and goes back into public water supply systems. They're all over the state. I'm not going to go into this too much, but Western, Kansas, Eastern, Central, it's pretty much all over the state. And we've had some that have had multiple systems in one city. So we had in Scott City, for example, a previous system that was then upgraded, and that's the current system that we have operational. So what's our scope of the sites that we deal with? And this is 2020 numbers, but to that date, we had closed about 2,700 contaminated sites. That's still left over 3,000 active. So we have a very large number of sites throughout the state that we deal with. So how do we fund this? Federal grants, we got about 6.2 million, 6.3 million in grants that we get. And those are primarily oversight grants, but some investigation and cleanup like through our Brownfield program. And then the bulk of the money comes from our state fees, our state general fund and state water plan. The big money comes from our tank fee fund, which is 1 cent per gallon on fuel that you purchase. And then we have Orphan gets some money out of our environmental stewardship fund as well. And Dry Cleaner has a fee on every time you go get something dry cleaning, there is a fee that comes back to us. And then we have cost recovery. If we have somebody go through their bankruptcy, we may do a settlement to try to recover some of the costs. Unfortunately, that's usually pennies on the dollar. Overall, just under $30 million a year is what we spend on sites. So the site I want to go over as an example is Ace Services site in Colby, Kansas. This was a federal Superfund site. So it's on the national priority list. And this was a chrome site. Hexavalent chrome was a contaminant that we had. That part of the state obviously has the water problems that they deal with. So we wanted to look at what was going to be the best way to treat the water and then get it back for beneficial use. That just shows where it's at. The facility itself was over on the east side of town, just off the highway. Timeline on this one, the facility operated 1960s into 1970s. Chromium platers have a large amount of hazardous waste that is generated during the process. In 74, 75 timeframe, KDHE asked them to put in a concrete retention vats and an evaporation lagoon, which they did. Then in 1980, a public water supply well, which was unfortunately not far from this facility, it was in the wrong spot for this to really work, became contaminated. We actually have more than one impacted well. In 1988, tried to get a services to clean up the problem basically. And then the next year they left saying they couldn't afford to do it. So we took over, KDHE did, removing some of the waste, hooking folks up that had potentially impacted private domestic wells, hooking them up to the city system. In the mid 1990s, EPA came in and did some removal actions as well. And then in 1995, EPA placed the site on the national priority list, what most people know as Superfund. In 99, they finally got a record decision, and that is basically how we're going to clean up this site. So the process is go in, investigate, you discover the site, investigate it, look at the feasibility, how are we going to clean it up, do the design, do the contaminant cleanup. In the case of a pump and treat system like this is a long period of time, and then monitoring. So it's a pretty lengthy process. Just an example of some of the waste, just the poor housekeeping, whereas the waste was getting onto the ground. The lagoon they had was unlined, which obviously we know better now, but there was a lot of waste chromium that was in the soil there, and that eventually got down into the groundwater. So this contaminated plume, it's about a mile east-southeast of the site, which actually for some of our sites is pretty short, but only about a quarter mile wide. So that gave us the opportunity to be able to pump this thing and treat the water. The problem is groundwater there, the contamination down in the 130 to 260 foot depth. So, it's a little ways down there, and you got to get it up. So this is just, bird's eye view. The lighter shaded part that you see there was what the plume was kind of at its worst before the pumping wells were put in place. We have a series, those red wells, there are several called EX wells, those are extraction wells, and a series of wells were pumped to pump it back up to a treatment system and then be treated to drinking water standards and then back into the system. The current contamination that's below, I believe it's 100 for chromium, is that little darker shaded area. So the system is working. Unfortunately, with that lagoon that was there and the soil left in place and capped, we're going to be pumping on this thing for a long time. But where we initially were pumping in the 800 gallon per minute stage, we're now down to about 150 gallons a minute. And using the system and the storage system, we can continue to operate the system pretty much full time. So EPA in overall, from the time that they did the initial design, assessment all the way through when they turned the system over to KDHE, spent about $18.2 million on that. The state has to pay a 10% match on that. So we have about 1.8 million into it, to the point into 2014 when we took over this site. So the way Superfund works, EPA uses their money, state matches, and there's a point after the system is stable and operating correctly that is then, it's then turned over to the state. So that's where we are right now. City of Colby was really interested in some sort of beneficial use because they didn't want the treated water be discharged to a dry creek. They really wanted to be able to have it come back into their system. And the benefit there is that the City of Colby actually operates this system for us. And we provide the funding for the resin and for maintenance and different things. So it's a really good partnership. In the early 2000s, the system was constructed, starting in 2003. Now, one of the problems we found is that we had an underground storage tank site, a petroleum site that was contaminated, and the resin we chose, that EPA chose, was not going to treat that. So there's about a year delay while we put in a granular activated carbon system to pre-treat this, and I'll show that in a little bit. But it has 250,000 gallon influent and effluent water storage tanks, so we can manage the process. 2 ion exchange treatment trains, so we could have the treatment on one be going through there. When that resin starts to get used, switched over to the next one, order the resin to come in and replace the one that has been spent. And it's about, I think it's about $250,000 to replace the resin each time. So it's not a cheap system. And then it put a chlorination system on. So this could be used for the public water supply system. So this is the two tanks. You got the influent and the effluent tanks. Everything is in the building. The building and the tanks actually sit over part of the contamination. That's where the original facility was. The lagoon is just to the right of this. These are the ion exchange vessels. There's 3 vessels, and you have 2 trains there, 2 different series. Lots of piping, lots of valves. The system was designed so it could be dealt with remotely. We can monitor what's going on. The city, like I said, monitors all this, but KDHE can get in, our consultant can get in, see what's going on. If we're starting to have any issues, look at what the back pressures are, what kind of breakthrough are we getting through the resin. And then the city does, I don't know if it's daily testing with some hot kits to see, are we having any breakthrough? And so we can know when to switch over to the next train. The petroleum contamination, here we had 3 30,000-pound vessels, granular activated carbon. It goes into this system. We have a lead and a lag and a spare. So you use the first one as your lead out through the second one, and then over to our treatment plant over on the chromium. Once that first vessel starts to get some, whether it's pressurization because it's getting plugged or you get some breakthrough, then you switch to the second one being the lead, the third one becomes a lag, and then you just keep replacing the carbon and get it regenerated. It's a very good system. Our tanks program did a wonderful job getting that system in place quickly. It took probably a little less than a year to get it in place, but that's actually pretty rapid for design and install. So like I said, we had been managing this, overseeing this since 2014. The city operation definitely helps. We'll spend anywhere from $250,000 to $500,000 a year, depending on the number of resin changeouts. Since we've been able to drop the pumping rate to 150 gallons a minute by targeting certain intervals, that has helped a lot. So I think our resin changeout is actually more than a year in between changeouts. We did go and install a new remediation well that targeted a certain vertical depth, and that really helped us lower our pumping rate. Because one of the problems out here is that there's a lot of natural demand for the resin. And so even if you didn't have contamination, we're going to spend a lot of that resin as it removes some of the natural, what's naturally in the soil and the groundwater there. So targeting and getting that groundwater flow to where we needed it was a big part of reducing our annual operational cost. So that is all I have. We have quite a few systems that are doing this. We always look for a beneficial reuse. An example of another site we did was in Hudson, where we treated a dry cleaner plume and was able to put that by re-injecting that back into the aquifer. And that was a real good opportunity too, because then we weren't sending 650 gallons a minute down a drainage through a ditch to the river. That one had chlorides, higher chlorides too, so we were able to just pull it out, treat it, put it right back in, and not worry about chloride issues on surface water after that. So that's quick. Hopefully I caught us up a little bit. If there's any questions, I'm here.
You did great, Bob. And there's one question we're going to throw out here real quick from the chat from Don Whittemore. Are the procedures shorter today to allow faster setup to treat the groundwater, because the faster to pump and treat, the less time for the spread of a contamination plume?
Yeah, I would say we like to get in quick and be able to cut things off and keep it in place, and then eventually bring the plume back. But the amount of time it takes for us to find out about these, often we find out, decades after it actually happened. So I would say typically from the time you find out to the time a system's in place is probably a couple of years. By the time it's assessed, designed, you make sure you have the water rights. And in this case, the city had the water rights, and remediated water typically is not counted against water rights. So that's a benefit in some places as well. Timing for these kind of systems is still pretty lengthy. Often we'll go in and try to do something like a bioremediation or chemical oxidation in situ first to try to knock things out, but that doesn't work if you're too close to a public water supply well.
Yep. Thanks, Bob. Is there any other questions here real quick? Maybe time for one more if somebody's got one. Well, I'm not seeing or hearing one, but certainly I appreciate you talking to us today, Bob. It's not one that we hear enough about. Probably didn't get enough attention or profile to really get you the resources you need. Of course, that's an issue for all of us, as we all know. I'd like to take a moment to thank all of our presenters once again. I think, as you've seen, we've had a great lineup covering a whole host of issues, and again, bringing a lot of expertise and good experience. I hope you all enjoyed it. Again, I think you can send them a chat if you want to, if you had something that you didn't get covered while we're here. We are getting ready to head to break, and our next session will start at 9:40. So again, thanks everybody for attending, and thanks to our presenters.